All right, everyone, in this video, we are going to take a look at corresponding parts of similar triangles. So until we do that, let's just review how to do some constructions for certain types of parts of triangles. For example, let's construct median AD, altitude BE, and let's bisect angle C in triangle ABC below. So if we look at this, well, let's go ahead and set points ABC first, right? So let's call this A, this B, and this C. So the first thing we want to do is median AD. So remember, a median connects a vertex to the midpoint of the other side. So what we want to do is bisect segment BC. We put our compass on point B, swoop above and below. Our compass on point C, swoop above and below. And we use that to find the midpoint. I'm going to go ahead and mark that as a midpoint and then connect it with A. So now for altitude BE, remember an altitude goes perpendicular to the opposite side. So you have to put your compass on B, put your stylus on B, and swoop your compass on either side of point B to segment AC. And then you're going to use these two swoopies as your endpoints and go ahead and bisect that. Now this time you only need one arc from each thing, each endpoint, because you already have point B to go through. And our last thing, we want to bisect angle C. So to construct an angle bisector, you swoop with your stylus on point C, make an arc so that it goes through both rays, both sides of the angle, and then go ahead and reset your compass on each of those. And oops, it does not like when I kind of go that way. There we go. And we're going to bisect angle C, and I'm going to mark that as an angle bisector as well. So these are the types of parts that I'm talking about when we talk about corresponding parts of similar triangles. So our first one is we are going to construct two similar triangles. So I want you to draw any triangle and using a scale factor, construct a similar triangle of a different size. So my first triangle, I'm just going to do an acute scalene triangle. Let's call it triangle XYZ. And for my scale factor, I'm just going to use a scale factor of 2, just because that's the easiest. So what I want to do to construct my scale factor of 2, I'm going to start with ray X prime, Y prime. And I'm going to set my compass to the distance of segment XY. And then I'm going to go ahead and, the Y prime shouldn't be there yet. And I'm going to swoop twice the distance of segment XY. And that's where I set my Y prime. I'm going to do the same thing. Actually, I'm going to copy angle X. That's actually going to be my plan here. I'm going to copy angle X. So to do that, I'm going to make an arc strike through both rays or both sides of angle X and copy that onto my X prime location. Then again, I set my compass to this distance and copy that distance at point X prime and go ahead and copy angle X. And then I'm going to go ahead and then copy segment XZ by setting my compass to the distance of XZ and then at X prime copying that twice. I'm going to set this point as Z prime. And then I can go ahead and connect point Z prime to point Y prime. Now, I'm doing this, of course, without an actual compass, so mine might not look similar, but yours should. So again, I used the side angle side triangle congruence shortcut. It's actually the similarity shortcut, not a congruence, but I used side angle side. You could have also done angle angle if you could have copied. You would technically have to do angle side angle because we wanted a specific scale factor here. But once you set segment X prime, Y prime, you could have copied angle Y onto Y prime and then done that as well. It's a little bit trickier to do side-side-side similarity simply because we're doing a scale factor. So what we want to do is we want to construct a pair of altitudes, angle bisectors, or medians. And I want you to just pick whatever one you like. Which one is easier for you? So let's go ahead and construct a pair of angle bisectors. So I'm going to bisect angle Z. So again, to do that, I swoop from angle Z, and then I swoop, swoop, and then I go ahead and I construct the angle bisector, and I'm going to do that at Z prime. I'm going to swoop, swoop, swoop from each endpoint, and construct the angle bisector. That doesn't look perfect, but let's just pretend. And then what I want you to do is use your compass to compare this distance with this distance. And for mine, what we should notice is that the angle bisector in my similar triangle is twice the length of my original. And if you noticed, that corresponds with my scale factor of 2, right? The same thing should have happened whether you would have done an altitude or a median. And that leads us to our conjecture. If two triangles are similar, then the lengths of the corresponding altitudes, medians, or angle bisectors are, the word is proportional to the lengths of the corresponding sides. So whatever the original scale factor is, the altitudes, medians, and angle bisectors will also follow that scale factor. For the second part of this investigation, we're going to look at the opposite side ratio, okay? And your book has us do this twice, but we're just going to go ahead and do it one time, all right? So we're going to draw an angle and we're going to label it A. And you want this to be pretty big, okay? So I'm going to put point A here, and I'm going to extend the rays. So you do want this to be fairly big. And on one ray, we're going to locate point C so that segment AC is 6 centimeters. So go ahead and take your ruler and measure this, and this should be 6 centimeters. And on the other ray, we're going to locate B so that AB is 12 centimeters. So here's B, and this should be 12 centimeters. That's what we should have. And now what we're going to do is we're going to draw segment BC. Okay. We're going to construct the angle bisector of A. So again, put your stylus on point A. Swoop from each of those arc strikes, swoop, and construct. And we are going to place point D where the bisector intersects BC. Finally, we are going to measure and compare CD to BD. So we're going to compare this piece with this piece. And then what I want you to do is write a ratio. So what is the ratio of CA to BA and CD to BD? So CA is this, which we knew was 6, and BA, which was 12. So 6 to 12 is what to what, okay? And what you should notice is that whatever happens here, and you might get a decimal, for example, like you might get, it depends really on the size of the angle that you had. So for example, maybe this is 2.1 centimeters, and this is 4.2 centimeters. I'm just picking some numbers here that's probably not accurate. But if you notice, 2.1 and 4.2, excuse me, we want to look at these ratios, and one of the things that we do when we have ratios is to compare their cross products to see if they're proportional. Or you can simplify each ratio or divide the ratios by themselves and look at the, divide the numerator by the denominator and look at the decimal value you get. in this case here, you should get that these are equal. So when we compare these ratios, the ratios are equal. It does ask you to do this again, and if you want, go ahead and do it again with AC being 10 and AB being 15, and you should end up with this conjecture. The angle bisector opposite side conjecture says, a bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio as the sides that form the angle. Okay, let's just break that down one more second. So let's say, again, we have this triangle. This is triangle A, B, C. Let's call this segment little a and this segment little c, and let's bisect angle A. What this conjecture says is that the ratio of A over C equals, and then our opposite side, let's call this P. I wanted to make this a different color. Let's call this P and this Q. A over C is P over Q. So again, here's how I remember this. A and P connect, so they go in the numerator, and C and Q connect, so they go in the denominator. That's what this conjecture is saying. I'm going to stop the video here, and then I want you to take a look at the examples, and then go ahead and do the video 2 so that you can and check your answers to the examples.